Okay, this is question one from exercise 8F. That was the exercise on logistic growth. So it says that Newton's law of cooling states the rate of change. So the rate of change of something's temperature. Let me do that as d temperature d time is proportional to the difference between its temperature and the temperature of the surrounding environment. All right, anytime something's proportional, we have to have a constant of proportionality. So the difference between its temperature and the surrounding temperature. Okay, object, so when T is 0, the temp is 100. When T is 10, the temperature is 80. And when T is 20, the temperature is 65. All right, got that down. So we need to find a differential equation to model this problem. Well, that's part A right there. So A is done. That will explain anything. Now, notice that K value is probably going to be negative because we would assume that the temperature would decrease. So that K is probably going to end up being a negative number, but we can just leave it as K for now. So we just need to find that, and then we need the temperature of the laboratory. So our goal is to find, for part B, we need to find T0. The fact that we have these three values tells us something. This means that we're going to have to solve a system of equations. Okay, so let's set up the first one and see where we can get with it. Okay, so when the time is 0, well, first off, yeah, there we go. So let's solve this differential equation. So I would have dt is equal to K, and then if I bring my temperatures over, 1 over T minus T0. That means bringing that over to here, I get 1 over T minus T0 dt is equal to K dt. Taking the integral of both sides, I end up with ln of T minus T0 is the same, or I'm going to be plus C, but that's the same as KT plus C. I'm not going to move my C around. So that gives me e to the kt plus c is the same as t minus t0. So a e to the kt, I've already dealt with my c, is then plus minus t is the same as negative t0. So what am I solving for? We're finding the object and temperature. Okay. So T0 is in fact T minus A E K T. Okay. Doing some substitutions into here. If I start with my first value, so T0, or T is 0, the temperature is 100. That would give me my temperature of the lab is 100 minus A, because it'd be A e to the K times 0. So the initial temperature is 100 minus A. Okay, let's do that with these other ones as well and see if we can see a pattern here or something we can use. So the time is 10 minutes later. The temperature is now 80 degrees. So the temperature of the lab turns into 80 minus A e to the 10K. Okay, well, there's not much I can do to solve that just yet. So let's move on and see what else we can find. Let us do this. So when time is 20, the temp is 65. So T0 equals 65 minus AE to the 20K. All right, so I need some way of combining these functions together to make them make sense. So there is a connection here that I can see right away. This has AE to the 10K. This has A in it. So if I take and I multiply this by e to the 10K, I'd be left with that right there. So I get T0, A, T0, sorry, taking a little bit longer than expected, e to the 10K is the same as 100 e to the 10K minus A e to the 10K. Boom, 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 we're good. So doing a little work right here, I can solve for negative A e to the 10K is the same as T0 minus 80. So T0 e to the 10K equals 100 e to the 10K plus T0 minus 80. Getting my T0s together, I would have T0 e to the 10K minus T0 is the same as 100 e to the 10K minus 80. If I divide out a T0, I get e to the 10K minus 1 is 100 e to the 10K minus 80. So basically what's going to happen with this is we are going to end up getting, because I've shown that I can solve this system of equations in terms of to solve for T0. So I'm going to now solve these two for T0, and then I'll set them equal to each other. I'll be able to solve for K, and with that, I'll be able to do that. So if I do that real quick, in order to combine these two, again, if I multiply this by e to the 10K, I would get e to the 20K, because when you multiply, you add coefficients, so that's what we got to do. So that's going to be T0 e to the 10K is equal to 80 e to the 10K minus A e, and now that's going to be to the 20K Again, solving this for that negative value, I get T0 minus 65. So T0 e to the 10k is equal to 80 e to the 10k plus T0 minus 65. Doing those solutions again, same exact process. T0 e to the 10k minus 1 is the same as 80 e to the 10k minus 65. My initial temp is 80 e to the 10k minus 65 all over e. That's an e to the 10k minus 1. All right. Now what I'm going to do is I am going to set T0. Those two are equal to each other. So if I do that, I have 100 e to the 10k minus 80 over e to the 10k minus 1. And that is going to be equal to 80 e to the 10k minus 65 over e, oh my gosh, e to the 10k minus 1. Well, if those two fractions are equal to each other and they have the same denominator, that means that 100 e to the 10k minus 80 is equal to 80 e to the 10k minus 65. If I move that over, I'd have 20 e to the 10k is the same as 15. So e to the 10k equals 15 20ths, or e to the 10k equals 3/4. So 10k is the same as the ln of 3/4. So k is equal to 1/10 ln of 3/4. Goodness gracious, this is painful. All right, so now all I have to do is I have to take this here, substitute it back in to there, and I should be able to find out what my initial temperature is. So that would turn into T0 equals 100 E. Well, if I take and I multiply 10K by 1/10 ln 3/4, this just becomes ln 3/4 minus 80 all over, and the same thing's happening there, E ln 3/4 minus 1. So that would be 100 times 3/4 minus 80 all over 3/4 minus 1. 3/4 of 100 is 75. So 75 minus 80 all over 1/4, negative 1/4. So my initial temperature is 20 degrees. Now I did that by hand. You could also just plug and chug with your calculator. So, what a pain in the rear end. So my initial temperature, or my temperature of the laboratory, this is 20 degrees. Now I need to find the temperature of the object after another 10 minutes has elapsed. Okay, the temperature is going to be well, we now know what the original temperature is. We just need one of these equations that relates the original temperature to the next one. A to the 10K. I'm sorry, I'm just looking at things. Because now I know what K is. I think I can just use this. I think that'll work. No, it won't. All right, so now we just need to solve out once we have 20. Um, Sorry, my brain is not processing where I can find my equation that I want. Um, oh, I'm such an idiot. It's this one that we're going to use. We're just going to rearrange it. I think. So 20 is the initial temperature. I'm going to use this one right here and I'll find my value. We're after this temperature minus AE to the 1/10 ln 3/4 times 10, and we know that this is 80. Sorry, 80. So now I can solve for E. So negative 60 equals negative A times 3/4. 3 and times 4. So 80 equals A. I think that works. So from that, I should be able to get my values here. So rearranging this again, I can do T equals T0 plus AEKT. So the temperature is 20 plus 80. Thank you. 80 E to the ln to the 1/10 ln that times a further 10 minutes would put me at 30. And I am super lazy, so let's just use my calculator because this video is already getting too long. Silly thing. What was it? 20 plus 80 times E 1/10 ln 3/4. And then I'm just going to do this 30 times, not 300. I can do this because I'm a big boy. Yeah. Let's see what's going to happen here. So about 53.75. I guess that makes a little bit of sense. I really hope that's right, and I hope that that makes sense to everyone. Good luck.